the path of a satellite orbiting the Earth causes the satellite to pass directly over two tracking stations A and B, which are 50 miles apart. When the satellite is on one side of the two stations, the angles of elevation at A and B measured to be 87.0 degrees and 84.2 degrees, respectively. How far is the satellite from station A? How high is the satellite above the ground? We assume that the two stations are on the ground level, A and B. Since we were told that the angle of elevation at A and B measured to be 87 and 84.2 respectively, meaning from A and B looking up at the satellite, the angle of elevation from A, 87, is larger than the angle of elevation measured from the station B. Another piece of information is that the satellite is on one side of the two stations, so we need to either draw the satellite on the left-hand side of A or on the right-hand side of B. If we were to draw it on the right-hand side of B, looking up, the angle of elevation at B is larger than the angle of elevation at A. Because of this, we will need to put the satellite on the left-hand side of A. We then draw a straight line from A to the satellite. That angle is the angle of elevation, 87 degrees. From B to the satellite, that angle is the angle of elevation. It is 84.2 degrees. Another piece of information given is that the distance from A and B is 50 miles apart. The 3 points A, B, and the satellite S form a triangle. This is not a right triangle, and so to solve it, we will use the law of sines. We label the side according to the opposite angle. And so the distance from A to the satellite is B. This is the side that is opposite to the angle B. If we need to, from A to B, we label it S because it is the side that is opposite to the satellite in this triangle, and the distance from B to S is A. The law of sines states that sine of A over opposite equals sine of B over opposite equals sine of S over opposite. In this case, A has to be an angle inside a triangle, B has to be an angle inside the triangle, and S is an angle inside the triangle for us to use this formula. This angle 87 degrees is not the angle A that we are looking for or we're interested in, but this is a straight angle, and so this angle A that we're looking for is 180 degrees minus 87 degrees, which is 93 degrees. This 93 degrees is an angle inside the triangle. In a triangle, the three angles add up equal to 180 degrees. Knowing the angle A and B inside the triangle already, we can find the angle S by taking 180 degrees minus the sum of the other two angles inside the triangle, which is 83 degrees plus 84.2 degrees, or we simply take 180 minus 93 minus 84.2, and this is 2.8 degrees. We now can substitute these into the law of sines, which is sine of A is 93 degrees, over A, which is an unknown, equals sine of B is 84.2 degrees, over B, which is another unknown, and sine of S, which is 2.8 degree divided by the opposite, which is 50. There are several equations here, but since we're looking for b, we will use the last equation, which states that sine of 84.2 degrees over b equals sine of 2.8 degrees over 50. To isolate b, we can cross multiply or multiply 50 to both sides of the equation and then isolate b. This is 50 cross multiply the knowns, sine of 84.2 degrees divided by sine of 2.8 degrees. We then use a calculator to evaluate this expression. This is 1018.306, which is approximately 1018 miles. Make sure the calculator is in degrees mode because the angles inside of the triangle is given in degrees. For part B, how high is the satellite above the ground? This height is perpendicular to the ground level. And so we're looking for the height from the satellite to the ground, knowing that the distance from A to the satellite, we just found it was 1018 miles. And the angle, this is not the same angle A that we had before, but this is the angle of elevation, 87 degrees. This height is perpendicular to the ground level, so therefore this is the right triangle. Since this is the right triangle and we're looking for the height h, we can use trigonometric ratio. This is the right triangle. The side that is opposite to 87 degrees is h, and 1018 is the hypotenuse. To use a trig function that involves the opposites, the angle, and the hypotenuse, we would use sine. Sine of 87 degrees equals the opposite h over the hypotenuse 1018. From here, we can isolate h. H is 1018 times sine of 87 degrees. We can then put this in a calculator and compute that this is 1016.9 or approximately 1017 miles. This is how high the satellite is above the ground.